Good day, everyone. Welcome once more to Insight Tutorials channel. Today, my name is Peter Ogbaji. Today, we're going to be doing biostatistics, or rather statistics. And for today's coverage, particularly for students that are preparing for exams and have found it difficult in these very topics, we're going to be running you through calculations across the student t-test, the z-test, the sampling distribution, the standard error of the mean, the standard error between two proportions, and we'll carry out various hypothesis testing. So for a start, we're going to start with the student t-test. Let's go. All right, so like I said, we're going to be starting with the student t-test. Most of us have been asked, perhaps have thought, what is the student t-test? So it happens that the student t-test was an idea that was conceived by an English statistician by name William Seeley Gosset. His name is William Seeley. So William Seeley Gosset was working under the Guinness Brewery Company then in 1908. And he actually carried out a test to analyze small samples, all right? Small samples in a company. And then he carried out that work. And then it happens that then the Guinness company was not allowing individuals to record their research work under their own personal name. So William had to impute the word student. He had to record his work under student because he was an employee there. So he had to record it under student. So hence, that's how the word came, student t-test. So what is a student t-test? A student t-test is statistical test that is used to determine if there's a significant difference between the means of two groups. For example, you want to do a test between the mean blood pressure of males and females in a particular community or a population. Or you want to do the average weight of the man or the woman, just when you're comparing two means, you are said to be carrying out the t-test, or what we call the student t-test. Now, the student t-test is only effective under certain conditions. Number one, it is when the sample size, n is less than 30. Number two, it's also when the standard deviation of the population is unknown. Number three, it's when samples are normally distributed, or we can say normally distributed samples. So once these three conditions are met, you can carry out student t-test. So we're going to do a typical example of the student t-test. All right, very importantly, there are some key assumptions of the student t-test that you need to know. And the first of it says that the samples are independent. Number two, the samples are randomly selected. Number three, the samples are from normally distributed populations. Number four says that the variances of the population are equal. So these are the key important assumptions of the t-test you need to know. So let us go straight into solving a question under the t-test. All right, so we're going to go into the student t-test example question. The question says, A health facility conducted an experiment to compare the mean weights of males and females. The weight of the participants was recorded, and the data summary is given in the table below. Alpha level equals 0.05, and we're given a T critical value of 2.1009. Test the hypothesis, the null hypothesis, and state your conclusion. Follow the steps to conducting the hypothesis test. And so we have that question given, and this is it displayed here on the board. From our question, we're given our level of significance. Our level of significance as our level of significance as alpha level of 0.05, and our T critical value was given as 2.1009. So we are told to actually conduct the hypothesis testing for this particular question. And before we do that, we are instructed to ensure to follow the 5 steps of the T-test. And so the 5 steps of T-test are: number 1, you state the null and the alternative hypothesis. Number 2, you're going to actually choose your level of significance as well as the alpha level, and also determine your degree of freedom. And then number 3, you're going to calculate the T-test statistics. Formula is going to be displayed here. And then number 4, you're going to make a decision. Then number 5, you draw a conclusion. These are the standard 5 steps you need to follow in calculating a T-test question. So you see, those are the steps actually displayed on the screen there. So let us follow those steps in solving this particular question. So number 1 step is that we're going to state the null hypothesis. Now, the null hypothesis and the alternative hypothesis are the hypotheses that are made at the beginning of an argument, right? And then at the end of time, we'll conclude with one of them. So the null hypothesis is the hypothesis of there's no effect, there's no change, there's no difference, right? So the null hypothesis say that the mean of the smokers is equal to that of the non-smokers. Or you will say that there is no statistical difference between the average mean of the smokers and the non-smokers. That's what the null hypothesis say in symbol form. Alternative will say that the mean of smokers is not equal to the mean of the non-smokers. Or in what form I can say that the null hypothesis says that there is no statistical significant difference between the mean of smokers and that of non-smokers. But alternative will say there is a statistical significant difference between the mean of smokers and non-smokers. Or yeah, there is. So that's the first thing we're going to do. Number 1. Then so number 2, we also look at the level of significance. Level of significance, which in the question was given to us 0.05. Then we have to determine our degree of freedom. So determine our degree of freedom. So degree of freedom is n1 plus n2 minus 2. And it happens that our n1 is 10 and our n2 is 10. So our degree of freedom will be 10 plus n minus 2, which will give us 18. 10 plus n, 20. So the next thing we're going to do is to calculate the T statistic. Now, I'll need to show you something here that is very important. You know, the formula for the T test is x bar of 1 minus x bar of 2. That is the mean of the first group of smokers minus the mean of non-smokers, all over the square root of the pool variance in bracket of 1 over n1 plus 1 over n2. Now, there's something you need to know. You know, x1 is the average of the smokers. x2 is the average of the non-smokers, which is 69. This n1 and n2 are the sample sizes of the smokers and the non-smokers. Now, this SP means the pooled variance. Now, this pooled variance has a formula of its own. So you have to look for the pool variance first before you're able to compute the T statistics. So the pool variance SP is given as N1 minus 1 S1 squared plus N2 minus 1 S2 squared all over N1 plus N2 minus 2. So in essence, for us to be able to find the t-value or the t-statistic, we have to look for the pool variance first. All right. So we're going to do that right away before we come into solving for the t-test. So the pool variance is equal to, now we already found the degree of freedom here. You know it is 18. N1 plus N2 is 18. So we can simply just replace it with 18. So this, our N1 is 10. So we're going to say 10 minus 1 times this pool variance of X1. This is it, 3.14 plus N2 is also 10 minus 1. And X, the variance of the second group is 2.1. All over this, of course, is 18. Now, in terms of in continuity, we're going to have it that this is going to be 9 times 3.4 plus 9 times 2.1. This is all over 18. Now, in continuation, our pool variance will be equals to, so I'm going to do this on my calculator, and then we're going to get the answer. So this is going to be 9 times 3.4. So this is 30.6 plus 9 times 2.1. This is 18.9 all over 18. So if we sum this up, plus 30 plus 18.9, we have 49.5 over 18. Our pool variance will be equal to 49 divided by 18. We have 2.75. Having gotten the pool variance, we can substitute now into what the t value into this the formula of the t statistic, so that we'll get the t value. So t is equal to our x bar 1. Our x bar 1 is 72. Our x bar 1 is 72. So we have 72 minus our x bar 2, which is 69. All over the square root of our pool variance is 2.75. Our pool variance is what we've got in is 2.75. And we have 1 all over the sample size of the first, which is N1, plus 1 all over the sample size of the second. So what we have here now is 72. So 72 minus that, that's going to be 3. It's going to be 3 all over the square root of. Let's solve for this bracket. If we are to solve for these brackets, we're going to have something like, remember, this is 1 over 10 plus 1 over 10. If 1 over 10 divided by 1 over 10, we're going to have 0.1 plus 0.1. So obviously, we could do something like this is 2.75 in bracket of 0.1 plus 0.1 plus 0.1. So we have the t value to be 3 all over the square root of 2.75 times 0.2. And if we do that, 2.7 times 0.2, we get the square root of 0.55. Our t value is going to be 3 all over. What's the square root of 0.55? The square root of 0.55 is 0.742. 0.7442 approximately, or yeah, we can say 0.74. Yeah, let's see, 0.042. So 3 divided by 0.742, it happens that we have it as 4.04. So our t value is equal to 4.04. And remember that we were given a t critical value of 2.1009. Now, we are at the third stage of the t-test. We've stated our null, we've written out our level of significance, and we determined our degree of freedom. We found the t value, And the next thing we have to do is to make a decision. Now, there's a general law that will guide us in making that decision. All right, so from our solving, we found out that our t value is 4.04 and our t critical value, t critical was given to us as 2.009. The fourth thing we have to do is to make a decision. Now, there are general laws that guide us in making decision in the student t-test. The law says that if the t value is greater than the t critical, the decision we'll make is that we reject HO, where HO means the null hypothesis. That's if it's a contraction, if the t value is greater than the t critical, we will what? We would reject the null hypothesis. But reverse is the case also that, but if the t value we got is less than the t critical, we fail to reject HO. So what this means is that we're going to compare. Now, this is one condition. Another condition is that sometimes you can have a value that falls within the range of this particular t value from the t distribution table, because this means positive and negative. But let us use this decision to make. Let us use this to guide us to make a decision. So it happens that the t value we got was 4.04 and the t critical value is 2.1009. Notice that the t value is actually greater than the t critical. So the decision we're going to make out of these two is that this t value is greater than this. So look at our decision. We reject null hypothesis. So I'm going to make a statement and say that since the t value is greater than the t critical, we reject HO. Now this is step 4. Now step 5 is conclusion. Step 5 is conclusion. Step 5, so because we reject the null hypothesis, we'll say that there is a statistical significant difference between the mean weight of smokers and non-smokers. All right. So we're going to at a particular level of significance, of course, at 5% level of significance. So continue to say that there is a statistical significant difference between the mean weight of smokers and non-smokers at 5% level of significance. So we have come to the end of this particular question. We'll go to the next question under the Z test. Okay, so we're going to solve a question under the Z test. And what is the Z test? Z test particularly is used for when the sample size is greater than or equal to 30, and also when the population standard deviation is known. So this is population start again, I beg. The z-test is used particularly when the sample size is greater than or equal to 30 and when the population standard deviation is known. If you notice, unlike the t-test, the sample size is less than 30 and then the standard deviation is unknown. For z-test, once you see that the population standard deviation is given and then sample size is greater than 30, that is a z-test. So we're going to quickly solve a z-test question right away. And so there's a question here that says that A cereal manufacturer claims that each box contains an average of 500 grams of cereal. A consumer advocacy group suspects that the boxes are underfilled. They randomly selected 36 boxes of cereal and found the average weight to be 495 grams with a standard deviation of 12 grams. Carry out a null hypothesis test and reach a conclusion. So before I solve this question quickly, I want to take you through the steps that you will be using in solving a typical Z-test question. Just like the T-test, there are 5 steps. Number one is to state your null and alternative hypothesis. Number 2 is that you're going to look out for a way to choose, as just like in the T-test, you're going to choose your level of significance, and also you're going to find a corresponding Z critical value, because for every corresponding level of significance, there's a corresponding Z critical value. If you're giving your let me say your alpha level as 0.05, the Z critical value will range between minus 1.96 to plus 1.96. If you're given an alpha level of 0.01, your Z critical value will range between minus 2.58 to plus 2.58. But the most commonly used is alpha level of 0.05. So that's number 2. You're going to choose your level of significance, which has a corresponding Z critical value. So they give you your alpha, your level of significance as this, then your Z critical value will be this. They give you alpha level as this will be your Z critical value. Then number 3, you're going to compute, you're going to find the Z statistics using the formula that you're seeing on your screen. And then number 4, you're going to actually make a decision, number 5, and then conclude. So we're going to go straight into this question following those steps that we've just stated here right now. So the first is that we're going to state the null and the alternative. I like stating them in symbols. Now pay attention. What is the argument of the Z-test? The Z-test argument is hinged on the population. Yes, the population's average. So looking at this question right now, we are told that a cereal manufacturer claims that each box contains an average of 500 grams. Now, a consumer advocacy group suspect that the boxes are underfilled, and they randomly selected sample size 36 boxes, and then they found out that out of 36 boxes, yeah, it had an average of 495 grams. So there are 2 averages here. There's average of the sample. This is sample. This is sample. Let's say we call it sample mean. And then we have the population mean, which is the average of the population. Now, it happens that in this very question, our sample, they took out 36 boxes. And when they sampled them, they found out that the average weight of those 36 boxes were 495 grams. Right? And then they found out also that the weights that the manufacturer claims to be the cereal, or the population weight of those cereal bags, he said it's to be 500 grams. So the argument will really be hinged on this particular population mean. So the null hypothesis will say that there is no significant difference in the sample weight of 495 and the population weight, the population mean of 500 grams, right? That the weight of the sample, it does not differ from the weight of the what? The population. So we are going to write it that there is no significant difference between this and that. So we'll write it as this. This is like in symbolic form. And then the null hypothesis, the alternative hypothesis will say that there is a significant difference in the mean weight between the sample and the what? The population. So this is the argument. So we have done step one. This is step one. So the second thing is the level of significance. And it happened our level of significance in this question is 0.05. Now, to every significance, to every corresponding significance, is a corresponding Z value. So if the level of significance for the Z test is given as 0.05, your Z critical value will be given as plus or minus 1.9, because this is a range. It's a range, right? Now, so you have it that your negative Z critical will be minus 1.96, and your positive Z critical will range between plus 1.96. So number 3, we are going to find the Z value, and the formula for the Z value is given as the sample mean. This is called the sample mean minus, this is called the population mean, all over the standard error. Now, this is the standard error. Now, the standard error itself has a formula, and that formula is standard error is equals to, this is what you call standard deviation population, or the population standard deviation, all over the square root of n, where n is a sample size. This is a sample size. This is a population standard error. Population standard deviation. This is population standard deviation. This population this sample size. This is the sample mean. This is the population mean, and this is standard error. So let's look for the standard error and then input it into this question. Before we look for that, we need to write out our values. So it happens that the population average of the cereal box was given as 500 grams. The sample average was given as 495 grams. In our question, we have a sample size of 36 boxes, and those 36 boxes have a population standard deviation of 12 grams. All right, and this is sufficient enough for us to input into this. So let us find the standard error first, looking at this value. So standard error be equals to 12 all over the square root of 36, and this is going to be 12 over 6, and 12 divided by 6 is 2. So our standard error is 2, as shown there. So our Z value, now this is the population, the sample mean, which is 495 minus 500 all over the standard error. Now we have gotten it as 2. So this will give us negative 5 over 2. Our Z value, if we do 5 divided by this, we're going to get negative 2.5. Now we have gotten our Z value to be negative 2.5. Now, what is our Z critical? Because we need to write these two out, because the stage 4 is that we're going to make decision. All right. So our Z critical value is given as, remember, look at it. So it is plus minus 1.96, or let me just say it's 1.96, but we know that it's negative and positive of it. So having found that, we're not going to do stage 4. Stage 4, we're going to make a decision. And there are general rules that helps us to make decision in the Z test. Let me make space here. So we have number 4. And number 4 says that if the Z value is greater than the Z critical, we reject the null hypothesis, which is HO. Reject the null hypothesis. But if our Z value is less than our Z critical, we fail to reject HO. So, but there's also other criteria you can use. Sometimes you have to check if it falls within the given range. For example, for this Z test now, for this particular question we are solving, there's what we call the normal distribution curve. And normal distribution curve helps us to gauge the Z critical value where the range is false. Now, if this is the average, from this point is negative 1.96. From this point is positive 1.96. Now, at this point, we call this point the rejection region. We call this point also the rejection region. Sorry for my write-up. Rejection region. Now, this point is called the acceptance region. So what this means is that every value that falls between this minus 1.96 to plus 1.96 falls at the acceptance region, and we cannot reject null hypothesis under this condition, right? But anything that goes below 1.96 or above positive 1.96 is at the rejection region on the two tails, right? This is a two-tail test, right? So the value we got, take note, look at the Z value we got is minus 2.5, and we have a Z critical of negative positive 1.96 approximately. Now, does this value of minus 2.5, does it fall within this range? Obviously, no. Within this minus 1.96 to plus 1.96, you cannot find a value of 2.50. So it falls this way. It falls this way in number line. After 1, you go towards 2. So it falls at the rejection region. So we're going to use that to make a decision in this regard. All right. So we're going to say, since, remember, we're going to use this because obviously, yes, minus 2.5 is less than 1.96. Of course, we'll have said we'll fail to reject, but we will not, because we're looking at this range now. So since a Z value in bracket of negative 2.5 does not fall within minus 1.96 to positive 1.96, which we call the acceptance region, we fail to reject the null hypothesis. So that's our decision. And stage 5, we're going to conclude. What this means is that there's no sufficient evidence to reject the null hypothesis statement. That's what this means. We fail to reject it because this value is not found here. This minus 2.5 is not found within this range. Okay, so conclusion. There is no, because we fail to reject, we say there is no significant difference. Significant difference between the mean weight, the weight of the cereal box in the sample and the mean weight of cereal in the population. So we have concluded, we've come to the end of this particular question. We've been able to cover the Z test and the student T test. Please follow us up on our next outlines of topic to be covered in terms of the sampling distribution, the standard error of the mean, the standard error between two proportions, as well as hypothesis testing and other biostatistics and classes. Thank you very much. So I believe you've learned something today, the student T test and the Z T test. So please do well to like, comment, share, subscribe to our channel, and always reach out for more tutorials updates. Thank you very much. I remain your tutor, Peter Ogbaji. You have a nice time.